So I finally fixed this screen. We finally have the right slides, week 4 of 5. This week we're going to look at, oh, this is actually wrong. We're at week 4, so we are going to look at some fairly advanced stuff today, mostly like, we'll look at projection and we'll look at how to like manipulate models a little bit more using outside sources. So I think what'll happen, so I've been kind of changing the schedule as I learn a little bit more about what the group is interested in and those sort of things. So this week we're going to go over some advanced stuff. Next week we're going to go over more advanced stuff. I think next week we're going to go over, if you haven't seen, there are people in the Slack channel talking about a thing called GAN space, which is just a library that helps you sort of find what we call features. So we'll talk a little bit about that. And then maybe what we'll actually do is we're going to look at some audio stuff today. So maybe what we'll actually do next week is look at that GAN space to generate some features, and then we'll actually manipulate them using, manipulate those features using audio in the next class. So that's going to be like, that'll probably be like most of the class. And then obviously, since that'll be our last week, we will also talk about sort of next steps for everyone. I've heard a lot of questions from people just about like sort of how to keep learning and like what they should be doing next and where to keep training on and that sort of thing. So I'll go over a little bit of stuff just about like sort of how to keep working with this. And obviously you're all more than welcome to keep using our Slack channel to continue along and share work. I added a new channel in our Slack channel that is just, I think it's called like share projects, which is basically if you have projects you're working on, like please feel free to share them there. That way people even outside this class will be able to see them. I also am happy to, like we have the class webpage. So if you have work that you want to share, like please let me or Leah know and we can add that stuff there as well. And then lastly, I think what we're going to do is do some sort of like group class, like after, like maybe 2 weeks after our last week, where we'll just like do like a, I know Moises has been interested in doing a live stream. So I think we might try to do something where it's just like, we come back together for a little bit and share projects. So Lee and I will look at that this week and sort of announce when we're going to do that. It'll probably just be like this same time, but at a later week. It's optional to attend. It's optional if you want to like record a video and just like have us play a video of you presenting your work. If you want to present it like live, I think we might try to put it on like a YouTube live stream so that people could watch in. So if you're interested in public speaking or not interested, just a word of warning there. We can work around like sort of how best to set that up for everybody. But yeah, I think that'll be a fun moment. Like Lee and I like are trying to share more people's work. One, because it gets you recognized, and two, it like helps us promote the class as well. So we'll try to do some of that. Lastly, I've posted a link in the Slack channel for Calendly. So if you want to sign up for a one-on-one with me, you're more than welcome to. Basically, it's like 20 minutes, 30 minutes or so, like of you like just getting to ask me questions that you might not want to ask as a group, or maybe it's just specific to the project you're working on. So you can go ahead and ask that or sign up for one of those there. It's mostly the slots I have available just like outside of work time. But I'm happy to, if there's a specific time that you want to meet, I'm happy to try to see if we can make that happen. But I definitely recommend that you use that time because it is time to sort of ask me questions. But I'll also say it's better if you come with specific questions or like, here's what I'm working on and I want to try to figure out how to do X, Y, or Z. If it's just the two of us hanging out, it's fine. But like it's better if there's like direct questions you're trying to figure out. Cool. So what are we going to do today? We are going to, oops. So here's the schedule for today. We're going to do some quick breakout groups like we usually do, just to have everybody talk with each other and hear how things are going this week. Then I'm going to quickly show like a really quick demo of things that some people asked for that I added into our generation notebook. And then we're going to do mostly projection and audio reactive StyleGAN today. So we'll talk a little bit about how projection works. We'll take a break and then we'll demo the projection, and then we will do the audio reactive work as well. So that's about it. So I'm going to have Leah kick us off with what we're working on, what we're going to talk about today.
Yeah. So I know last week we showed you like manipulation techniques you can do with your model, and also like perhaps you've finished training and made some animations. And so I'll put you in breakout rooms to kind of share what you learned and what you need. And then we'll also, like always, come back to the group, and then maybe a couple of people can show and tell a couple of things that they've made and ask questions. Cool. So I'm going to put you into breakout rooms for 10 minutes, and then we'll come back after the time is up.
Oh, I've just realized I have a question now. If that's right now whilst everyone's waiting.
Yeah, go for it.
I've just realized I need to stop my training, and I'm not sure I know how to do that. Other than just shutting down the
That works.
VM. Just do that.
The other way to do it is you use the NVIDIA-SMI command, and then you get a PID from there, and then you write like kill all -9 and then your PID.
Okay.
But honestly, stopping your machine is simpler. So I recommend just doing that.
Cool.
All right, looks like everybody is back. So there's a couple of things that I want to talk about, and then we'll take a couple questions. So I know that everyone, or at least I've seen a couple people talking about just sort of like how to know when their training is done, or just like how to like think about like how long should they train for. And I think there was also a conversation about like in the Slack about like sort of the burned out images / like seeing lots of differentiation in the way that things are training. So let me just talk about a little bit about how things actually train. So training is not, I wouldn't say it's random, but it has like a random element to it, in the sense that the way these things learn, if you know, like you can sort of look this up on different machine learning things about what's called backpropagation. But essentially what happens is it takes a very small batch of images from your data set, and then it produces that sort of that GAN and discriminator adversarial network. But it takes on a very small set, and then it like updates its weights based on that. So as you're going through these trainings, like it will sometimes veer off in weird directions and then come back, because depending on the data set it's being pulled from, it can like learn certain behaviors and then come back. So a lot of times you will see things that will sort of like, they'll glow in a weird direction, and then after a little bit more training, they'll come back, and then they'll go in another weird direction, they'll come back. And the reason we train these things for a while is that because with that process of sort of like going back and forth and back and forth and back and forth, they end up in more of a like correct location by doing that. So that's generally why it's like recommended you train things for longer than you expect to, because you will generally get a better average result through that longer training. In this class, obviously, like because we have very limited time on GCP, like sometimes we shut things off like rather quickly once you get like some good results. But I would say like I generally train my models for like 5,000 steps, or like, sorry, not steps, 5,000 K images minimum. And that gets you in a much, much better place. But on a server like we have on GCP, that can take upwards of a week, depending on different parameters. So generally training for longer is better. There may be moments where it starts to what we would call training too far. Probably rare that happens for most of your cases. But again, sometimes it can be like it overshoots and then it comes back. If anything, you will generally see that like for the first 1,000 K images that you're really running on, you'll see a lot of variation. That next 1,000 to 4,000, like to get to 5,000 total, it's going to even out a lot more. And then like like at the end for the last 3,000 K images or whatever, like you're going to be like, is this changing at all? And it's very, very minute details that are changing. So just be aware of that, and know that like generally the longer you train stuff, the better it's going to get. But there's a lot of diminishing returns the further along you get. So sometimes it just ends up being like so I want to move on to a new project and see if that like creates something new, or do I want to like stick with this one, that sort of thing. But yeah, I just wanted to mention that because I think like there is a lot of just questions around like how long should I train this for? Am I getting good results? Am I not getting good results? There's a lot of just sort of general messiness in those early like stages of training that sometimes if you like overreact, you'll like shut down a model when it's still like not yet ready to like go, or like you'll see like, oh, this looks like it's doing something bad and I should just restart it. Not always true. In general, I just recommend letting it train for a little bit longer if you can. Sorry, yeah, go for it.
So I know that last time you mentioned that we, even if we think that we know what pickle file we want, we need to choose the one after it. So I've done that, but I'm still having trouble finding fakes in my seeds that I've seen originally, even if my pickle file directly corresponds to the pickle file.
Yeah, I've also experienced that, and I think it's some of it is that in your fakes file, some of that are also, I need to actually pull exactly what they do to generate those fakes, but those fakes are both fakes from with like just random seeds, but they're also random truncation levels. So some of them you're seeing that you might really like might be like a 0.5 truncation level, and then you're like generating samples that are 0.7, and you'll never see those two match up. So like it is pretty hard to actually like find that exact fake that you saw. And I will probably try to like actually pull that from the repo to actually see what they actually produce. It is randomless, or it is sort of random, but it's like there is a seeding to it. So you could probably pull like something of like about what they produce. But yeah, it is hard to actually find those particular fakes in your generations.
And do you recommend like how many seeds do we generate, or how far do we go to just see like what is the actual kind of lay of the land?
Yeah, that's another great thing. So Kaina and I were talking about this earlier, which I don't think yet last week. I don't think I did a good job of sort of explaining how I use those interpolations to sort of understand my model. So I generally produce like those noise loops. So I'll generally produce a couple of those just to sort of understand my model. So I might do one at like a very small diameter and then one at a larger diameter, and like doing the ones at larger diameters with a longer frame rate will give you like a bigger sort of view of the entire space. So I'll generally just produce those just to sort of see what my data set is. And then in terms of generating images to sort of see what I have, realistically, like if you can produce 1,000 images, that's good, but like that's never gonna like, that's obviously like kind of annoying and hard to do on Colab. But that's my general recommendation, is like produce like a couple sets of 250s and 400s, or sorry, 4 sets of 250 images through Colab, and then download those, because downloading them is like, if they're really big files, it's hard to download those on Colab, or you move them to your drive folder, whatever. So generally like producing a big set will just help you sort of understand the model a little bit better, which is why I generally produce, so like when I'm producing a model, I generally like I let it train for a week, and then I download all these images, and I don't really, so like it can go months between me like starting a project and finishing a project, like just in terms of like understanding how like what's there and what isn't. So this is definitely not a fast process. If you are used to fast feedback loops, this is not a fast feedback loop sort of material, at least not yet. So yeah.
And sorry, I have a lot of questions.
That's fine. Yeah.
But pickle files take like at least an hour to download. I don't know if that was just.
Yeah, they're big.
I'm wondering if there is any other way of going around it, and maybe like downloading more of them at once.
Yeah, so there's a way to like zip them up. So you could zip up a couple of them and download them. They'll still be big and large. I know Caitlin posted some notes in Slack on using a GCS instance, which I think Esteban and other folks have done. You could try that. I also think, was it Caitlin or was it someone else? Someone else found a way to actually link GCS also to Colab. So like that would be the quick, oh, it was Elena. So that would be the quickest way to do it, which is like post all of your work from GCP into GCS, and then link GCS to Colab, and then basically you never have to download stuff, because of all the internet cables we have at our homes, like it's gonna be way slower to move anything to our local computer than it is to keep it all in Google Cloud services. So I'd probably recommend that as the fastest way. At some point you will want to download that to make sure, like, because GCS is charging you to like for storage and other things. So at some point you will want to move stuff either to a Google Drive file or to download it. So eventually you want to download it, but the hope is that you can move things as quick as possible around. And it sounded like the GCS stuff is probably the quickest way to do that. Although I personally haven't done it yet. So I should probably look at that so I can actually help people with that as well. So why don't we jump into a little bit of lecture, and then we'll have a lot of time at the end of class for more questions if people have anything. So I want to finish up what I was saying about generating noise loops. So I was telling Kynan that I sort of generate noise loops as a way to just sort of understand my model. Sometimes I share those, but those are like almost like demos. Like I sort of just share them as like, here's a demo of a model I'm working on, like that sort of thing. What I tend to do after generating a noise loop and just sort of finding like, oh, I like these things, is then I'll generate a bunch of seeds. And I'll download those seeds and I'll look at them literally one by one, and I will pick out a couple of my favorites, and then I will do a linear interpolation using those seeds. So that will sort of be my final piece, is like doing the linear interpolations of seeds. And that way I have more control over things. I can like actually take the video and drop it into After Effects and maybe tweak things if I want to. That's sort of my process. And it just sort of is what I found works well to have like a good control. but also to sort of understand what's available to me. Yeah, the hardest thing with this stuff is if you're not used to working in sort of what we call generative art fashion, which is like you act more like a curator. If you're used to trying to find like the perfect image, that perfect image, you will spend a lot of time in your life trying to find the perfect images in these models. So I would say like find a good model or find a good image in the model, but don't try to find the perfect ones. It's just going to take you a lot longer. With that in mind, actually, I want to quickly share one of the things that I did work on, which I think some people had talked about last week, which is when they have, let me get my slides here. So I have a thing, I added a thing to our models called what I call neighbors. So I think we had talked about this last week, which is just like, if I have a seed image that I really like, how do I find the, like, how do I look at other stuff near it to see if there's a better one nearby? So what I actually did is I wrote a little command inside of our StyleGAN notebook to help you do that. So this is inside of that Colab notebook. This is the same one that Lee and I shared last week. But I just want to quickly share how this works. So I'm just going to open this in Playground because it's on my Colab Pro. So the way this works is that you just go ahead and install all of your repos you need. So this is just going to install a repo. I'm also just going to, I'm going to download Leah's network file here. And just to save us a little bit of time, I'm going to skip the image generation step. This is the step where you generate seeds. So let's say that I generated these images. I found the seeds I liked, and I really liked, say, like seed 5 or something. So this is what's called near neighbors. And the way this works is that it's the same sort of command. You just change out this line, which is just generate neighbors. You feed it a seed. And you can feed it multiple seeds, but for this demo, just for time's sake, I'm going to send it just one seed. So let's say I like seed 10 from the images I was looking at. What I can do now is there's 3 or 4 new commands here. So there's a command called diameter. So if you imagine, again, that 2D space where we have an image that you want that is right here, and you want to look at the images around it. So imagine that there's like a circle around it. That is really a terrible way to demo this. But basically, like, imagine that there is a small space nearby. And you're setting that space with diameter. Now, if you set the diameter really, really small, you should generate images that are sort of in a small location. If you set it a little bit larger, like let's say we set this to 0.05, that'll give you a little bit more of a space around those images. Lastly, you want to generate like how many samples of that random space nearby do you want to generate? I'm only going to generate 10. You could generate up to like, I mean, you can generate as many as you want. In this example, I'm just going to do 10 just to make this happen quickly for us. And lastly, there's a thing called save vector, which I'm just going to run to show you what this does. I know people are asking, like, how can I get vectors out of these images that I see? So I added a command that will actually save these vectors out for you. It's a little bit hard to actually reload them, but I'll show you how to do some of that in the projection work as well. So I'm just going to run this command really quickly. And hopefully this runs relatively quick. If you haven't noticed, this is always, setting up this TensorFlow plugin is always takes the longest time. Basically, this creates files, and then, so the very first time you run it in Colab, it's gonna be slow. After that, it'll be much faster because it caches all of the commands. But this is the slowest process and also the hardest part of demoing. All right, so when this starts to generate, I'll just open this up and we can start to look at what the results are. So you'll see it creates a folder called Generate Neighbors. Inside that folder, if we get our numbers here, yep. So the first thing it'll do is it'll generate what the seed actually looks like. So you could just double click on this and it will open it over here. The problem is it opens at like full 1024 by 1024. So let's try to make it bigger. So this was the seed I was trying to generate around. So let's look at some of these neighbors. So you'll see over here that now we've got neighbor 0, neighbor 1. Now remember, these are randomly generated, so it's not ideal to sort of know exactly how these two things are located next to each other. So this is one of the neighbors, so we can kind of compare these two next to each other. You'll see the coloration's a little different. You know, you're getting less of that spike, that sort of thing. So now this is basically like you could download this file when you're done and just look at all of the near neighbors nearby. Now it's important to remember that like now you have lost that seed, right? The seed is still the original image, but any neighbor nearby it is not the same seed. So you actually have to like, and this is probably something that isn't possible today, like if you don't know how to use Python or anything, but basically these also get saved out as what are called NPY files. This saves out the vector. So now we can actually pull this vector in and use it in other cases. I'll show a little bit of that in when we talk about projection. But for the time being, like this is probably the cleanest way to sort of get some of these vectors back out. This also helps you explore sort of the space around it. So again, if I also double click on neighbor 2, you'll see this is again sort of a similar image, but each of these is slightly different from each other. Well, this is a way to sort of like look at all of the images in a local space rather than trying to just generate seeds randomly. Does it make sense? Okay, cool. Any questions about that? Go for it, Espan.
Could you explain a little bit more about the values for the diameter?
Totally, yeah. So the diameter is, again, every time I use the word diameter in here, it's mostly it's an analogy, but essentially diameter is, remember that our vector space for StyleGAN is -1 to 1. So if you were to think of a diameter of a space as 1 whatever, that would take up half of the space of our whole latent space, right? From -1 to 1 takes up one region of that, or one unit of that would be a large diameter of that space. You could set this to 1, or you could set it even 2, and it would actually cover that entire space. Making it smaller reduces your space down to that same sort of, to a smaller area, right? So if you were to imagine these as vectors of like 0, 0, 0, 0, 0, all the way to like 512 dimensions, if you made your diameter to look within like 0.05, then your max values would be -0.05 to positive 0.05 of that space to look at. All this does behind the scenes is it generates a random 512 dimensional vector within this sort of negative and positive space, and then it adds it to whatever your seed is. This actually should be probably called radius, but whatever, diameter works for now. But basically, small values will give you a very, very close approximation of the seed. A larger diameter will give you like more randomness within that space. Cool. Okay. Yeah. Any other questions about near neighbors? You're welcome to play with this. And if you have other questions, I'm happy to answer them. Cool. Okay, let's go back to this is my guy here. Where'd this one go? Let me find my slides here again. What happened to them? Okay, well, we'll find them in a second. Oh, there they are. Okay, so that's sort of a demo of latent spaces. So real quick before we go to break, I just want to cover how projection works. So I think some of you have probably already played with projection, but essentially projection is the idea of taking an image from outside of your data set. So let's say we trained it on a bunch of faces, right? So it's the FFHQ model, but my face was not in that data set. So this is a way of taking a face from outside of the faces data set and finding the closest approximation in your data set, or like, sorry, this should say in your model. So find the closest approximation in your model. So basically like finding my face in the FFHQ model. And like the idea behind this, behind the StyleGAN folks building this, was that if you find an image on the internet of someone's face and you're like, is this a real face or not? You could project this into the model And if you find the exact match of that face in the model, that means it came from the model, which means it's essentially a fake image. So the idea here is that this is some way of combating deepfakes. There's lots of like questions behind how that actually works or whether that's actually feasible. It probably isn't in the long run, but that was sort of the idea. So if you were to project my face into the FFHQ data set, you would hopefully not find my face in there, right? Because like I was never trained in there and it shouldn't exist. But basically like this is a way to combat deepfakes, but also artists are finding cool ways to use it. So obviously I've described this as like, this is like finding the robot inside of Blade Runner. So the way this works is, let's say I want to find Harrison Ford's face inside of my latent space. So the way it works, it starts with a random position. It actually always starts at the very center of your model, 0, 0, 0, 0. It again, sort of similar like training, it like bounces around. So it tries to like figure out what is called the loss between this image and the image it's looking at in the model. It then determines a loss and it determines a direction to move in to try to find something better. It does that over and over and over again until it finds the closest approximation. So part of the reason, and we'll look at this when we generate these videos, is these videos sort of like they start in one place and then they like move iteratively, and that's this process. So that actually looks a little bit like this. This is why your output looks like this, right? So it starts with that generic woman, and then it tries to find the closest approximation to the image in the model. And I think this goes on for a long time. So like you can set how many iterations it should go to find it, right? So here you'll see it's almost like stuck in a space where it's like it keeps sort of circling this image. Eventually it actually breaks out of this. And it does find an image that I think, yeah, it starts to find an image that I think approximates Harrison Ford a little more. Until eventually it ends up in a place that is sort of like, I don't know, it's like the bootleg version of Harrison Ford. Like if you ever heard an actor described as like the B-list version of a celebrity, it's like that. So we're gonna look at how to demo this after the break. But this is basically the process for it. So, and there's inside of the generation notebook, there is some code that we're gonna run through after the break to sort of walk through this. This is the process for it. Now what's cool is, again, because we know what direction this is ending up in, we sort of have the, we also have the vector of this particular final image. So what we can do with that is we can actually take this vector, do another projection project. So let's say we project a different face into this model. We can take that vector and then we can actually interpolate between those two vectors. So this is actually an example of going from the Harrison Ford character in Blade Runner to C-3PO in Star Wars. And yes, that is as creepy as it looks. Like where it ends is like a rather like pretty creepy space, right? Because there are no robot faces inside of the StyleGAN FFHQ model, so it like finds a very weird looking face. Now I probably also could have maybe found something closer to C-3PO if I were to actually like train that, like do more iterations, it would maybe get closer and closer. If you remember that Mario example that I showed from like maybe the first week of class or second week of class, that's what they did here. And they just trained, they like the iteration, the number of times it tried to look for the closest approximation was just very, very long. That's why that video was like 2 or 3 minutes long. So we're gonna look at how to do this after the break. So yeah, so let's take a quick break. Let's come back at 24 after, if that works for everybody. Cool? All right, see everybody in 5 minutes. Okay, cool. So this is all in the manipulation notebook. So we're just gonna run, I actually restarted my notebook by accident. So we're just gonna restart this from scratch. So again, you just need to set up your, just run this first cell, which just installs all of the repo code you need. I don't think we need to run anything here. I'll just run this just in case. So we're gonna jump down here to projection. So for this example, I'm actually gonna run the FFHQ model because it's a little bit easier to understand, like finding a face within a model of faces. Like with Leah's like sort of drone footage, I don't know if we could like find another image that would match that. So that's a little bit of what's interesting with trying to do projection is like, do you want to try to project a thing that already like faces to faces? So maybe like finding another bird in another bird model, or do you want to like find something weird inside of like another model? Like those will work, but like in a different way. For this, I'm just going to use the FFHQ model. You're always welcome. This is how I have a hosted version of this on my drive. So if you ever just want to use FFHQ, you can always just grab this line of code and use it. It doesn't really affect me at all. So feel free to download this. So I'm just going to use gdown to get this down. So we come over here to my files. You'll see now I have my FFHQ file and I have my StyleGAN model. Or my StyleGAN folder. So the next thing we need to do is, let me just make sure that I'm in the right place. So PWD just tells you where you are, or like where you're working from. Interesting, this is not where I need to be. Okay, so sometimes this happens when you rerun the, if you accidentally rerun that first cell, it'll like duplicate, see how there's a StyleGAN2 inside of a StyleGAN2. Basically what I just need to do is go back a model. It installed stuff in the wrong place, which is fine. So as long as you're working inside of the correct folder, that's why PWD is always helpful. It just sort of tells you what folder you're working in. So I want to work inside the StyleGAN2 folder. So from there, we are just going to create a new folder that's called pickle, and then we're going to install another file that is called VGG Zhang Perceptual. Don't worry about what this is. This is basically how we run the metrics and the loss between our current image and the projected image. This is basically a model that allows us to do that sort of calculation and figure out where we are. This is going to create a folder inside of here called pickle, and then inside there it's going to install a thing, this file. So unlike previous demos of using Colab, where we just ran stuff that already was embedded inside the StyleGAN2 folder, here we're actually going to embed the code, like we're going to write some code directly in here. Now, I know that not everyone in here like knows how to read code or even knows how to use it. You do not need to worry about the majority of this. There's like a couple lines you want to tweak, but for the most part, you won't need to worry about any of this. But basically, like all you're going to do is run this, and this is going to install it directly into Colab, so it's available to us. So you're just going to come in here and you're going to hit Shift Return. This shouldn't take more than a second because it's just going to install some stuff to make sure it's working right. And I've tried to do a good job of also explaining like a little bit of the text before each of these cells to let you know. So when you come back to it, it like should make a little bit more sense to how this works. So last thing we need to do before we can actually upload our image is to just create a couple more folders. So anytime you see mkdir, that just means make a folder. So we're going to make a folder here. We're going to make one called projection. We're going to make one called images, which is our input, and make one called out, which is our output. So the last thing we need to do here is we now need to upload a single image to the projections folder. And this image should be probably a color PNG with a size of 1024 by 1024. So one thing you have to know about projection is that the image you input, or the model that you're inputting into, the image you're inputting into that has to be the exact same size. So this is the FFHQ, which is 1024 by 1024. If you were to use one of the 256 by 256 models, you would need to input a 256 by 256 image into it. So they have to match up perfectly. So what I'm going to do is in here, I'm going to find my projection folder. There it is. And I'm going to stick an image in here called images. So I'm actually just going to grab, this is probably going to be a little bit further down. I'm going to grab this guy. So again, this is our Harrison Ford example. I'm just going to grab this and I'm going to drag it into the images. And it looks like it's been uploaded. Yep, so it's now uploaded. So now that I've had this image uploaded, I need to run this line of code. So this line of code is actually what produces the projection. So there's a couple things in here you might want to tweak. The first is this line right here, which is file name. So this is basically what the vector file is going to be saved out as. So obviously this is not C3PO, so I just want to call this Blade Runner. That Harrison Ford image comes from Blade Runner, so I'm just going to name that. So when this gets saved out, it's going to be saved out as bladerunner.mpy, which is, I'm going to use this, or I'm going to show you how to use this potentially later. So this is a .mpy file. The next thing that you might want to enter in or edit in here is the number of steps. So again, this is how many steps it moves to try to find that closest place. Now, if you make this a really, really big number, like say I make this 5,000, it's going to definitely find the closest approximation to your projected image. So if you really want to find the closest thing, I recommend making this a high number. the downside of making this a high number is it's going to take forever to run. So for this demo, I am not going to put in a very high number. I'm going to put in a very low number. I'm going to put in 100. Basically, it literally generates, it like goes through each step, and that step costs you a couple seconds every time. So I'm going to keep this low just so that we can demo this quickly. But I wouldn't generally use 100 for my own work. I would set it to 1,000 or higher. So these are the only 2 lines you need to edit out of this. Everything else you can just sort of like blur your eyes and just ignore. Don't worry about it. So now that we're ready to go, I'm just going to hit Shift Return. Interesting. Oh, that's fine, right? Oh, there we go. Okay. So it's still running. So what it's basically doing is it's setting up, it's actually making a pickle file of that one individual image, which is kind of crazy, but that's what needs to happen. And now it's setting up everything to start training on. And this isn't really training. It's more like what's called optimizing. So now you'll see we're now running through the projector. And at each one of these steps, it's going to find how different is this image from this other image. And then the next step, it's going to move and it's going to keep doing that until it gets further and further along. So this will output sort of the steps as you're running. This last number here is kind of considered the loss. So basically, we should see this number go down pretty dramatically very quickly. So this is how different our 2 images were at that step. This is how different our 2 images were at that step. So it gets smaller and smaller as you go down. Now, again, just like your own training model, sometimes it bumps up or down a little bit, right? Because it's got some randomness or it's got like a guess in it. So it will sometimes guess in the wrong direction and then it'll be fixed the next step. So you'll see this has not really found a bad guess yet. It's still going down. In general, my guess is that at the 100 steps, it won't really it won't really have a bad guess because there's a big gap. If you set this to 5,000, you might see that this number like ticks up and down a little bit as you get further and further along. So ideally what we want this number to be is if this number hits 0, that would mean it found our image in the model. In most cases, it will never hit 0 because that image doesn't exist in the model. So in this example, you'll see it would hit at a loss of like 0.54, which is actually still pretty high, but not really worth worrying about. So one thing you can do, now that this is done, inside your out folder, you will see there are all of your steps here. So if I were to just go in and just double click on this step 100, here's the image it found. And if I were to double click on the target, which is this image with this file here, you'll see this is the image we were looking for. So clearly not the same, but like definitely like, you know, fairly close, I guess you could say. Like the hairline is kind of interesting. There's some similarities, even if they aren't all similar, right? So this is run. If I want to make one of the cool process videos where you basically like see it change iteratively over step by step, you run this next command. So this is going to look inside of this folder and it's going to convert all of these images into a video by just looking at the count. And then it's going to place our target image to the left of it. So again, this one, you don't need to know anything about what's going on in the code here. We just hit Shift Return. And this just made our video. So here's our video. I'm going to download this. That was ridiculously quick. So here you go. So basically, we started with this image on the left. At each one of these steps, we found a slightly better, slightly more accurate version of Harrison Ford. Although I'm really interested in this step. That's pretty interesting. That guy has long hair, and I don't know where the long hair came from. But anyway, we got closer and closer. Now, if I were to run this for 5,000 steps, you would probably get something more like the video that I shared earlier, right? Where a lot of times it might get stuck trying to get in and out of this one area, and eventually it breaks free. So a lot of times what happens is when it finds a loss and it says, hey, there's a certain amount of difference between these two images, it sort of guesses the next spot. And then as it guesses the next spot, it like tries to calculate that. So sometimes things will get stuck in like a certain location because it's guessing and the guesses are never right. So it can just sort of take a little bit of extra juice to sort of find the right location, which is why I would recommend, like, if you really want to find the perfect location, set that number of steps parameter to really high, because that's going to help you find a better location. Okay, so now we have a video out of that. Now there's sort of two ways that you could do this. I'm actually going to run this really quickly. So one thing to notice here is that you've now got this NPY file, right? And you can't really open this. If you open this, it's just going to look like a bunch of gobbledygook because it's actually saved in sort of like a special format. But this is now our vector. This will give us the vector of this step 100 image. So I'm going to come back up here and I'm going to rerun this. So I'm going to run this command with a different image in it. So let's actually do the C3PO version. So the first thing you want to do is like delete this image from your folder. So remember, this is with the inputs. So I'm going to find where my C3PO guy is over here. Go to desktops. So here is C3PO. I'm going to drag this new image now into images. So I'm going to run this exact command again, but this time I'm going to run it on C3PO. So the one thing I want to change here is to change the file name for this. I'm going to change this to C3PO. Is it O or is it a 0? I don't know, whatever, it doesn't matter. Anyway, so I'm going to run this again. So again, I'm only going to run this for 100 steps because it's pretty short. So this is going to run the exact same command. It's actually going to overwrite all of my steps in here. So if I wanted these steps for whatever reason, I would actually want to download this before running this again. For me personally, I don't care about these images. I'm fine to overwrite these. Really, all I want to produce is this .mpy file, and I'll show you why in a second. This is, again, finding these images. You'll see that 100 iterations is pretty fast, but it will be not very accurate. So like, you know, if you were to do this for 1,000 steps, it would be like multiply this amount of time times 10, and that's how long you could expect it to take. Sometimes it even takes a little bit longer than that because of some of these loss functions. Okay, so this one again got down to about 0.53. So if I just come back over here and I look at my out and refresh this folder, and I'm going to come down to step 100, which is the last step of the training process or the loss optimization process. And I open this, you'll see here's our creepy guy that is gold like C3PO, but definitely doesn't look like C3PO. And you'll also see that now I have a new NPY file here. So both of these contain the vectors of the location of that particular image in the latent space. So now what we're going to do is we're actually going to interpolate between those. So here is what we have, which is we're now going to load in these vectors. So the way you save the vectors is np save. The way you load them is np load. This loads it in and converts it to the 512 dimensional vector we need. So now we have Blade Runner and we have C3PO. What we want to do now is we want to interpolate between those two. And I'm going to do it, so let's just do it. This is what, 4 seconds? That seems fine. And the truncation value for these is always a little screwy. I usually do 0.7 just to be, like, that tends to be about what projection does. So we're going to actually create a interpolation between these 2 points, and then we're going to save this out, and then we're going to generate a video from it. Let's go ahead and do this. Again, if you were to do this for yourself with custom images, the only lines you would need to change are this first line and this second line. And this just generates, like, this says, hey, here's the first MPY file and here's the second MPY file. So all you need to do is edit. If you change the names of these, you'll want to edit these names. So we're going to run this. Okay, and if I refresh my folders over here, you'll see now I have a folder called Interpolations. and as I go through these, this is each one of these steps. So the first 0, 0, 0 should be that Blade Runner step. Yep, it's this guy. And then what we'll get at is at 288, actually probably 287, because this is zero based, we'll get the C3PO image. And since I'm at image 80, so or whatever, we can actually start to look at how this interpolation is happening. So here, this guy is starting to look a little bit more gold, starting to look a little jaundiced at the moment. So let's look at this one. This one's a little over halfway there. So it should be sort of in between. Yeah, and so we see like this guy is very gold. Looks like he's been using a lot of bronzer. His hair is starting to turn into a helmet, which is good, I guess. Some really creepy stuff in this. Almost done. Okay, so we just finished. If I refresh my folder here, you'll see that our last step, which is indeed 287, is our goldish kind of C3PO. So the last thing we're going to do is we're actually just going to make a video out of this. We're just going to take all these steps and convert it into a video. So the only thing you would probably want to rename here is you just want to rename what your output file should be. So we're just going to run this. And this just finished. And let me see, what did I name my file? Blade Runner. Okay. So here we go. So this is our video. We're going to download this. And there we have it. So we're now interpolating between two images that never existed in the data set. This is a pretty cool way to do this work. And I should also mention that when we talk about the near neighbors and how I was saying it's saved out an MPY file, you can use this exact same command to interpolate between your, interpolate between your near neighbors, right? So when the near neighbor saved out that NPY file, it's the exact same file format as this. So I probably deleted those, didn't I? Let me see if I have them here. Interpolations, so results. Oh, here they are. Okay, cool. So let's actually do this. So if I take one of these, like let's take near neighbor. Oh, you know what? This is a different model. This isn't going to work. Basically, because I did the first stuff on near neighbors on Leah's model, and now I'm using on FFHQ. It won't work the same way, or it won't work at all. But I could use, if I had done this on the FFHQ model, and these are the same MPYs, I could actually take these MPYs. So I could take a random face that I found using near neighbors. I could convert that to C3PO by grabbing one of these paths. So I would actually just copy this path, and I would just paste this path in, and this would work fine. Instead, what I'll get right now is I'll get a random face neighbor that I don't even know if it's going to be good, and it's going to convert to C3PO. But basically, you can use this exact command to generate any of your latent networks from an MPY file to an MPY file. So this might be helpful for folks. Just remember that it's sort of buried down here in the interpolation work. So that covers everything with projection. Does anyone have, or like what questions do people have about projection? Adam, go for it.
Just had two questions. First one, what's the difference between a vector and a seed?
Right, so a seed is literally basically it's a marker for a vector. So a seed is what's called a random seed. All it literally does is generate a random value that becomes a vector. Now, the reason that we want to use seeds is that a seed is literally what's called a random seed, meaning that when you use that seed, it will always point to the exact same vector. So it's basically a placeholder for that vector. And it's easier to input, like I want seed 12 than it is I want vector, and then you have to give it 512 dimensions of random large float numbers, right? So seeds are just generally better they're easier to sort of like remember. If you use this save NPY format, you can also do it and reference them by files. But basically, a seed is just a reference point to a vector.
So you would you ever do like a seed to a seed in interpolation, or is it better to be just doing the way you showed us here?
No, it's fine to do a seed to a seed. And in fact, that's how we taught it last week, right? It was just like generate some images, grab the seed you like, and go from seed to seed.
Okay.
That is, I mean, I would actually recommend that because it's easier. The only reason you might want to use the NPY to MPY is when there isn't a seed available to you, right? So when we make these projections, we're not given a seed at the end, or we don't know what the seed value is. So we have to find a way to get that vector in another format. And this is the way to do that.
Okay. And also, would it be possible just to add a latent 3 and a latent 4?
Yes. Yep.
Like,
yeah.
That would just be just adding the line and then adding something to the images?
Yep. So all you have to do here is if you add a latent 3 and then give it a new file, you'll just need to add it to this vector. You'll say latent, latent 3. And then, so basically all this does is says, give me all the interpolations between these points. And you can add as many points in here as you want. This last number here is the frame count. So actually what I would probably do is I would just say frame count equals, and then let's say 144, which again, frame count is based on what you're going to convert the video to. So let's say this is a frame rate of 24 frames per second. So you just want to do some math here. And then all I would do is I would change out. This is actually a good idea. I should just do this for this format. So I'll just update the notebook to say this. But yeah, you could generate as many latent spaces or as many interpolations as you want using just this line.
Perfect. Thank you.
Yep. Other questions? Moises, go for it.
Yeah, I had a question. I forget what it was called, what you taught us last week, where you were able to mix seeds.
Yep.
So with these MPY files, we could put those in that grid where you would mix them.
You could. The code doesn't support that now. I could add support for it, but right now it doesn't work like that. But ideally it could.
Okay. Yeah,
I'd also say like, yeah, right now those also, I think this was brought up last week, is like, it'd be nice if those mixing seeds gave you the vectors of what those mixing points were. So I could also like add a little bit to the code to do that as well. Yeah, all this is possible. It's just like, no one has requested this and I haven't written it yet. So like I added the near neighbors because a couple people requested it last week, and I'll probably just I'll update my repo to like add these other functions in there as well.
I'm curious, like the difference between interpolating from one seed to the other versus like that grid mixing. Is there much of a difference, or like that whole frame?
Yeah, I don't know if it's just like I don't know if the mixing seeds, I have to look at the code a little bit better, but I don't know if they're actually averaging the seeds or if they're actually adding them. Like, so averaging versus adding is a different vector process. I'd have to look and see like what they're doing there. They might be slightly different processes. They might actually be the same. But yeah, interpolating between, well, so the other thing is like, when the library was, I think interpolation is only something available in my library. Like the original StyleGAN library doesn't even have an idea of doesn't do interpolation. So that's been added. So yeah, it just might be that they never added that code. Any other questions?
So, quick one. Since the seed to vector relationship is predictable, it's basically just a hashing function. So in theory, it'd probably be possible to write the function that goes from vector to seed, which is a little more convenient for storage because you can, write down the seed versus memorize the vector.
Possibly. So it's using Perlin noise to generate a random seed, which is just like the way the code works is like it doesn't set it up like that.
Sure.
It probably could, but you probably could, yeah.
Okay.
I've never seen anyone do that. Reverse a vector to a random seed value, but I'm sure someone could, yeah.
I have a question. I saw it uses like a pre-trained model to calculate how different projection images from the image in the model.
Yeah.
Does it use also a 1024 by 1024 input, or can you use it for smaller images? Like my network is trained on 256.
It should work. So actually that model is not, it's a classifier. So actually what it probably does is it probably shrinks it down to whatever the classifier model size is, which is probably more like 256. Basically what this thing does is it actually takes your inputs and it calculates the inputs together, shrinks them down, and then does the classification, and then gets the loss, and then like goes back and does that step again. So it should be fine. Yeah.
Yeah, I asked this because I have like an error.
Okay.
With TwoFloat, but I'll put it on Slack.
Yeah, that sounds good. Yeah, there might be some errors with the way this code is written. It might be that like this was written essentially for FFHQ, and there might be some issues behind the scenes. Yeah. Any other questions? Okay, cool. So I'm going to go a little over time. I apologize, but I'm going to cover one more thing, which is using audio reaction. So I'm going to do like a very simple example of using audio reaction. So the thing to know about any of this work is that basically like it's very easy to manipulate any StyleGAN model with an outside source, assuming that there is a way for you to map the values of your input source to the output source. So in this case of the audio example we're going to use the volume of an audio sample. So we'll go from 0 to 1 in this particular library. So all we're going to do is map 0 to 1 to some value that we can use inside of StyleGAN. So remember, StyleGAN has a latent space that is -1 to 1. It has a truncation value that is, I don't know, negative whatever you want to positive whatever you want. But more likely, most people use it -1 to 1 or 0 to 1. It has things like feature vectors, which we'll talk more about next week. But basically, there's any way to manipulate these models, assuming that you have an input source that can be mapped to that. So you could technically map like a gradient of a color, which is 0 to 256 in 3 dimensions, right, RGB, to this model, right? You could basically take a, which actually would be a cool demo. Maybe one of us should try this. Like you could take a gradient color strip and use that to change a model, right? Basically take all the color values and then input that to output. So any of this can work. This is actually outside of StyleGAN completely. It's like more just like, how do I use Python or JavaScript or other things to create a vector or to change a value of my StyleGAN model? So that's all we're going to do. So we're going to actually do is we're going to do this, which I realize I don't think my audio, tell me if you can hear this. No, you can't hear it. Okay, cool. So let me figure out how to switch that really quickly. Video settings, maybe. Audio settings.
I think you have to select it when you're starting the Zoom.
Oh, I'm starting the Zoom. Interesting.
Yeah, like when you choose to share your screen.
Got it. Okay, let me see if I can do that really quickly. Oh, actually, you know what? I might be able to do this. Let's try this. Tell me if you can hear this. No, still nothing.
Maybe you can just go
to
in YouTube.
I'm gonna leave the channel and I'm gonna leave the Zoom and come back with that settings on.
I think what Moises said is correct. All you have to do is unshare your screen.
It might kick everybody off. Let's cross our fingers and hope this works. Actually, Leah's the host, so I think it'll work. I did not get to change my settings. That's interesting and annoying.
It should be when you share your screen initially, there should be an option to share computer audio. It might be in like the top bar at the top of your screen share.
This is the bottom left. The bottom left.
Bottom left, I guess.
You can try pressing Alt-S.
All right, can you hear me now?
Yeah.
All right, awesome, great. Okay, so I'm just gonna walk Leah through this then. Although you don't have the file. So here's what I'm gonna do. I'm gonna, okay, so now that you've seen what the demo looks like, I'm gonna show you how to do this process. You might not be able to hear the audio when we finish it, but I'll share these in Slack afterward. So we can sort of walk through how this actually works. So I'm gonna share my screen real quickly.
Yeah,
I have the files necessary for everything. Okay, so this is in a separate notebook. There's just for audio reactive stuff. So if you click this link, I did not update this link, of course. I am failing all over the place today. Okay, so let me do this then. Move this guy out of the way. And now on audio reactive. Okay, so okay, so this is the file. I will share this in the, actually, let me just share it in the chat right now, if you want to update the notebook to just, or update the slides to add this. Thank you. Okay, so this is a pretty straightforward demo. What you're going to do is just take the sound from one of your files, and then we're going to map that to a couple different things inside of StyleGAN. So let's start this from scratch because I don't really, there's a bunch of files already in here. So the first thing as always is just to install our StyleGAN files. And again, for this demo, I'm just going to use FFHQ because it's just a little bit easier to sort of see how things change. So our next step here is that we've got an audio file that we need to upload. So obviously you could drag your audio file directly into your folder here. There are some cool little features of Colab that allow you to sort of like create a little file uploading widget. So we're just going to use that for this moment. You just hit Shift Return and it gives you a little Choose Files guy here. And the video or the file that I want is in Downloads and it's this. So I had to play a lot with what file formats work with this particular type. I found that a stereo wave file will pretty much always work, whereas other files are a little iffy, especially how they're produced. So I actually end up going to like some online like file converter to convert things around to try with stuff. So if you upload an MP3 or an M4A, I don't think M4A works at all. If you upload an MP3, you might have a hit or miss problem. So try to convert it to a WAV file using like one of those online converters if you can. This is also a pretty short file. A longer file will take much longer to produce. So like I'm going to demo with a pretty short file, but you're welcome to find like a whole song or something if you want to. Okay, so now that we have uploaded our audio file, I'll just let you know, like this is a Bjork sample. Bjork songs work really, really well for this because they're weird already and like that make weird outputs. So if you're looking for something to sample from, Bjork is a good one. So this is a good, so this just uploaded this file here. So the next thing you want to do is in these two, these cells here. So this is going to point to my file. So this is already the right file. So, but if you want to change it, you just click on this and hit copy path, and then you just paste it in here. This is your frames per second. Probably leave it at 60 unless you like really want to, I don't know, for every reason you want to change this. 60 tends to work well for this though. The next command we have here, this is actually going to process our audio. So this is going to use a thing called SciPy, which I was talking with someone else from the Runway class about this. But basically SciPy has some built-in audio processing signals. So when I run this, it might download a new, like it might add a file, which is fine. But basically what it's going to do is it's going to take the volume of the, it's going to transfer, or it's going to like figure out what the, oh, interesting, WAV file is not named. Why not? Maybe I didn't run this. So it's going to convert signal, it's going to convert the volume to a signal. And let me show you what that looks like. So this is what this looks like. If you've ever seen any WAV formats or whatever, like you probably have seen this before, but you'll hear that song starts sort of very quiet, it gets loud, and it stops, and then it gets loud again, and then it sort of like does this like weird patterning here. I recommend that you, for experimenting with this, you not do like a full like song with like a 5-piece band or something, but you find something that is more an audio sample that actually has like quiet parts and high parts. So it might be an individual instrument, it might be someone singing, it might be other things, just to start with, because a lot of songs will just have like, they will never hit 0. They will always just be like all the way at the top of the levels. So for this model, I would definitely, like for this demo, I definitely recommend finding a sample that works with that. Okay, so this cell is then just going to install some code. This is basically some code that allows us to do things like generate our Z's from seeds. This is actually the code that I think, Caitlin, if you want to look at it, this is how you generate a seed. This is converting a Z to a W, so this converts our Z vector into W space, and this actually generates images in our W space. So if you want to look at this code, this is available for anyone to look at. You're just going to run this, so we save it to Colab. And now we're ready to actually generate our images. So there's a couple of things we want to do here. So what we're going to do for this demo is we're actually going to use the volume. So that volume, if we look at this map, it goes from 0 to 1. So what we're actually going to do is we're going to use the volume to interpolate between 2 seeds. So we're going to take seed 1 and seed 2, and when the volume is at 0, it's going to be the first seed. When the volume is at 1, it's going to be the second seed. And when it's somewhere in the middle, it's actually going to be in the middle. So first we need to pick our seeds. We're going to work off FHQ. I don't really care what the actual images are for this demo. So I'm just going to pick seed 75 and seed 100. From here, like, you don't actually need to touch anything in this code unless you want to. I'm going to add another line. I'm going to call it truncation value, and let's say it is 0.5. And I'm just going to, so now you have this option as well, which I'm going to paste in here. Is that right? Yep, that's right. Cool. So basically, these are the 3 values you can tweak. You can tweak what model you're using, what your seed values are, and what your truncation level is. So when I hit Shift Return, this is going to start generating our model. Now, it's important to know that you can't really control the length of these frames because you've already set your frames per second. So it is frames per second divided by how many seconds the audio file is, and that's going to generate how many images you produce. So this is going to, like, once this gets loaded here, it's going to generate our files. And really all it's doing here is, if you look at this line here, if you're interested in the code of this, all it's really saying is we're doing what's called a LERP, which is a linear interpolation. All we're doing is we're taking our first point, which is that first seed, our second point, which is the second seed, and then we're just taking the audio at the exact moment of the song. So this will either be 0 or 0.5 or 1.0. And all it's taking is it's saying, give me the value, or like basically the interpolation between those points. And once we've collected all those values into vectors, we then are generating this interpolation in the W space. So this will be a little slow. So this is just going to generate each of these images. Actually, this is fairly fast. I think the next version is going to be slower. While this generates, I'm actually just going to go ahead and show you what this ends up looking like, which is what Leah showed. Obviously, you won't be able to hear my sound. I'll get that figured out for next week. But all it does is it produces a video that looks like this. Oh yeah, you can hear it. We can hear it because I unplugged my headphones. That's how. That's the hack around it. But yeah, essentially, like, so this works really well, right? Because there's that nice little crescendo at the beginning. Then there's that stop, and then it works again. So like, this is a nice, like, sort of demo video. It allows us to do that. And you'll see, like, you know, at 0 you get this. At 1 you probably get this woman, and then you get sort of these interesting little like bounces between it. Now, if I had a video like this, would actually maybe be really interesting with something like an orchestra, where an orchestra might have a very, very, very slow crescendo, and you would actually see it sort of animate over time. And obviously my cat wants to sing along. So you could get some really interesting effects just by finding the right audio sample to generate this. Now, of course, this is a little limited because it only works between 2 steps. So it only works between 2 seeds. If you're interested in playing with this more, we can talk about ways in which you might change those effects, or how you might use multiple seeds, but it gets a little funky. So Moises, I think your question is what?
Yeah, I'm just curious if, I guess it's like if they're neighboring seeds, then that interpolation feels smoother, or like how you taught us how to do like that noise interpolation. So like the seeds are further away. Does that make it more generative between one part of the audio file and the other?
Yeah, so that's an interesting question. So you could find seeds that are further away, and what that will do is it will definitely make the jump between those two like better. So you could actually use like the near neighbors to maybe find a way to like generate that. The other option would be, so you can't really use this with noise loops. The problem with the noise loop is that it's completely like sort of uncontrolled. So you're not really controlling a lot of the effects. So we could think about like how you might actually use this to affect certain things. The problem is you have to find the right way to map stuff, right? So we're mapping 0 to 1 to that interpolation line, which already takes a 0 to 1. To map it to other things, you have to just find out how best to map those elements. I'm actually just gonna, well, this is almost finished running. So the next thing I wanna look at is how do we actually use this? So this is the code here if you wanna generate these into videos. I'm gonna skip it just because we are running like really long on time, is here. If you have any issues with running this, just let me know and I can like sort of help you walk you through it. So the next thing I want to talk about is, well, like, what if we did this for something like 0 to 1, where that could also be a truncation value, right? So let's actually look at how to do this with truncation. So again, we're going to take this time instead of interpolating between multiple seeds, we're actually just going to take one seed and we're going to change the truncation value of it. So in this case, what we're going to do here is we're going to feed in a seed. We're going to get the Z index from that seed. And then right here, you'll see Bug, you're killing me. Jesus Christ, come here. Heck, it's so loud. Okay, so we're actually just going to use that input value, so it's 0 to 1, as the truncation PSI. So, or truncation psi. I don't know why I always call it PSI. It's psi. So we're actually just going to take, again, the point in our frames and grab the audio at that sample. So we're going to run this exact same command. I don't think there's anything else I need to touch here. So
could you share your screen?
Oh, am I not sharing? I'm sorry. I must have hit a button that stopped sharing it. Okay, sorry about that. Okay, so let's talk about this. So we're going to use volume to control truncation. So in this example, I'm just going to have one seed. And what we're going to do is we're going to take the seed and we're going to grab the Z index or the Z's from it. And then we are going to we're going to change the truncation value at each of these points. So as we go through all the frames we need to produce, we're going to grab the volume at that exact frame. And then we are going to create an image from it. So we're just going to run this. This one will run really, really slowly. I think it's because we're altering the truncation so much. So let me show you, this is not the exact same example, but let me show you an example of how this will work. So one thing is, this is going to give you 0 to 1. Actually, I do have an example of this. What am I talking about? Well, maybe I don't. Okay, so let's see. So this is a truncation using volume. So you'll see, this is actually, we're mapping the truncation value a little bit differently. This is mapping it from -1 to 1. So at 0, which is the volume, it's actually at a -1 in truncation value. And when we hit 1, which is probably like here, actually probably here. So we hit a volume of 1, it's actually at +1 truncation. And you can find the 0, which is when it's at like 0.5 here. So this is a way of just, you're mapping the volume to new metrics of the numbers. So the way I actually did this is in a later cell. So in this cell, basically what we want to think about is we want to think about how do we map 0 to 1 to any other numbers. And there's lots of functions you can find on the internet to do this. I did this in a really hacky way, which is that so let's say we wanted to map it from 0 to 2. So the way to map volume to 0 to 2 is actually just multiply your value by 2, right? So if it starts at 0, 0 times 2 is always going to be 0. 1 times 2 is going to be 2. So this will convert your volume function to, or your volume to a space of 0 to 2, which then means you get a much higher truncation value. Now, the next line here is if I wanted to convert it from -1 to 1, what I have to do is you do some funky math, but it basically like you subtract half and then you multiply by 2. That now maps your numbers. Your volume is 0 to 1, but your output of our truncation value here is now -1 to 1. And this is basically the process for all of this work. So all you need to do is figure out what your input is, which in this case is volume, figure out what it's mapped to, which is 0 to 1, and then you need to take that to mapping it to something like truncation value. I could also map this to something like a latent space, right? If it's -1 to 1, I could map it to -1 to 1. The problem is that that doesn't really give me the best latent space values, because what I really want to, that'll just give me like a line from -1 to 1. If I mapped like that value to every one of the 512 vectors, it would just map it, but like that's not really good images. So it's actually kind of hard to like do this stuff. You have to sort of like mentally think about like how you're converting numbers, which is why I tend not to like focus too much on this in this class, because we're not really getting into like code, or this is like almost generative art world. So it's a little different, but this is basically all you have to do. So I linked to a notebook in this, this was sort of the inspiration for this class, this particular notebook. This is a gist by an artist by the name of Robert Luxemburg. You can look through this. What he actually does is, I think he uses some machine learning models to actually separate out the tracks of a song. So he actually has an instrumental track, he has a vocal track, he even has some different drums and some synth levels. So what he's doing is he's actually taking all of these different variables and mapping them to different things. So I think he's like mapping like he's mapping the vocal track to a feature vector called mouth ratio, which is like the mouth opening and closing. I'll show this more next week. He's probably taking some of the drums or whatever and converting that to truncation values. So he's doing a lot of different sort of like different manipulations of these states to generate these videos. Now this is like definitely like, if this is what you want to do for your final project, you could totally like spend a couple weeks doing this. It's worth looking at if you're interested in this sort of space, because he's doing some really interesting things with it. I just want to show you a really simple example to let you know that like basically what you need to do is you need to take an input signal and map it to your output in StyleGAN. So that's pretty much it. That's probably all we're going to look at for reactive audio. Next week I might do an example where I actually take a feature vector that we find in GAN space and map it to this, so that then we can use volume to change a feature vector. But in most part, like this is pretty much all we're going to cover for reactive audio in this class. If you're interested in more, like I'm happy to talk about it in our one-on-ones, but this is just sort of the basic level. Okay, class is over. I'm finally done. If you'll have questions, we can talk about stuff. I'll upload these videos to our Slack channel as well, so you have access to them. But basically your homework is just to keep generating models or playing with models or doing other things. One note I have been forgetting to make, which is something that Esteban reminded me of. If you are done using GCP, please make sure you delete your project, or you at least delete your VM, your virtual machine. If you don't delete your virtual machine, GCP is going to keep charging you because it charges you a certain fee it charges you a very small fee compared to using your GPU. So when your machine is on, it's charging you for the full rate of using a GPU and things. When your machine is off, it's charging you for storage space. Basically, it's keeping a little hard drive available for you that you've been using. So make sure you delete your virtual machine as soon as you're done. Otherwise, you will be getting extra charges. Thank you, Esteban, for reminding me of that. I'm sorry that you paid a little extra. But yeah, just remember that is like that is a big thing you want to do. Also, if you forget and like a year later, you just check your bill and you get charged $100. I'm sorry, but also this is the reminder to make sure you delete your virtual machine. So homework is just
bucket.
Oh,
a bucket
yeah.
as well.
Yeah, clean your bucket as well if you're using a GCS. Yep. Esteban, go for it.
Could you explain at the beginning of the process of doing projection, you said that we have to link two pickle files. One is the model that we are using, and the second one was, I was kind of lost in that part. Could you explain that? That's my first question. The second question is that, as you know, I've been working with audio as well, and I've been trying to link my abstract art with audio. So can I use like two seeds from that previous interpolation that I did and link it to my audio somehow? Is that how it works?
Yeah, I mean, essentially, well, so you can't use it from a previous interpolation. Basically what you need to do is you need to grab the seeds from the model that you're working on, find the two seeds you want to work with, and you could use that first example to interpolate between that using audio. And then your first question was, there are two pickle files, and there are two pickle files. The first one is the model that you're working with. So basically you want to upload your model. The second one you don't need to worry, or the second one you don't, in projection, the second one you don't need to worry about. Basically just install it, don't think about it. All it does is it does some classifying for images. It helps us figure out how far away two images are from each other, but don't worry about what it actually does. Just run the code and you don't need to touch it, yeah. Okay, so who has other questions before we finish up class? Kyle, go for it. Sorry, I can't hear you. Can anyone else hear Kyle?
I'm sorry, I keep muting myself. So I'm going through that 512 model generation or retrain. And I was noticing that, is there anything that I need to do in order to name the pickle file? Like right now, I copied what was in there and it was like, on the last part of it is like -10,000.
Yeah.
Do I want to, and then, when I was going through all this, I was looking at the old StyleGAN2 models and some of them had like an 88,000 at the end of the pickle file name. Some of them have no number at the end of the pickle file name. But I noticed when I run the retrain, it picks up that number and it says training for, number of K images. But before that, it says it's, it starts with that number, that whatever's at the end of that file.
Yeah, so that 10,000 represents, in some ways, how many K images the model has been trained for. Because we're using transfer learning, it doesn't really matter what we name that number. I just generally name it 10,000. That way I know it's like coming from a pre-trained model. Also, my guess is that if you set it to 0, like if you were to just name it -0000, there might be some stuff that StyleGAN2 does that would be like trying to think about it like early training process. In StyleGAN1, the number definitely mattered because in StyleGAN1, they used to do a thing called progressive growing, which was basically a way, where you were in the training process was how many images you were, or the image resolution it was training at. So for StyleGAN2, it's less important, but probably still good behavior, just set it to about 10,000. In StyleGAN1, it was very important. So, so with StyleGAN2, it's basically just saying like, hey, this has already been trained and we're pretty far along in the training process in case there's some piece of StyleGAN that is actually like trying to use the how far along you are in training to do certain things.
Okay, thank you. So I had another question. Sorry, somebody else wants to go, but I have a couple. Is there any advantage? So I'm doing 512 by 512 square. Is there any advantage to using Skyfly nil over your fork because of the raw TF records, or was there something else that I wanted to worry about there?
Maybe the raw TF records, and that it's just a smaller file size. If you're doing square stuff, this actually came up with the Esteban and Ertuman. If you're doing square models, I think using my fork is perfectly fine. In fact, Esteban and I are debating there might actually be an advantage to using squares on that model, but I'm not convinced of that yet. But like, it's possible. I would say if you're doing square stuff, using my model is fine.
And then, sorry, one last one, which was after the GCP credits expire. I know that you're a big fan of Paperspace. Do you have a video of doing a very similar process on Paperspace?
I do, yeah.
Okay.
I have so I can link you to those. Yeah, and I'll talk about this a little bit more next week. But like after GCP, since GCP is pretty expensive, you have some options, right? So it's like Paperspace I find to be the easiest setup, but it's fairly expensive. It's not as expensive as GCP, but it is like fairly pricey. You want to use a P5000, which is 76 cents an hour or something. So it's definitely not cheap. Your other option is to use Colab, which is free, but will need to be reset every 12 hours, so it can be kind of annoying. And then in the middle, your middle option is Vast, which is like going to be cheaper than Paperspace, but not free, and will also require more server setup and stuff. So it's kind of like, I'll talk about this more next week, but you kind of have some options about where you go from here if you want to keep training and don't want to like use GCP and get charged a lot of money. So it's kind of just like your choice.
Excuse me, do you happen to have a Docker file for Vest?
So the Docker files, if you use the, I don't.
I use the Docker files that they have on vest.ai, but it's not the correct CUDA version. It's not.
Yeah, that's. Yeah, so that's one of the
pain to install.
It is a pain to install. I can talk to you a little bit separately about what you might do to get around that. I did find that I could get it to work with one of the default. I think there's like a default TensorFlow one, and I found that that did work. But we can look at it, and I can sort of. I haven't used Vast in a couple of months. I've sort of like stopped using it for various reasons, but I can talk you through sort of the steps of that.
Yeah, it would be great. I also bought a second-hand GPU on eBay, like you posted on Slack. So in 1 month, I'll see.
We can also talk about we can also talk about that next week if you're interested. Like I am building my own. I'm building my second GPU setup here. So if you're interested in, you're going to do this for like the next year or so, and you really
well, if you train it for more than 1 month, then you already get your GPU cost out of it. So.
Yep, totally. Yeah, so we can talk about that next week as well, like just sort of how to recoup your costs if you want to build your own machine. Kyle, go for it.
Piggybacking off of that, I would imagine one of the advantages of having your own machine is that if you wanted to do something like in the world where like you had built-in interpolation and you wanted to take data and then run these interpolations like live, is it I don't know, is that a big deal? Like if I wanted to send that up to Paperspace or I wanted to send that up to somewhere else, I mean, obviously there's a lot of code that has to be written for that, but is there like one service that would make that easier, or is that just really like you want to have your own machine?
I would probably recommend your own machine just because it's like going to be easier to control that. I do know that Runway, which we didn't really cover anything about Runway in this class, but I'm finishing up a Runway class opposite this. Runway's just released a option on their platform called Hosted Models, and they charge, I think it's like ½ cent per request. So basically, like you could set up a web page or like an installation in a museum, and you could have them send a request to their servers, and you would get back an image. And that is like ½ cent. I think it's ½ cent. Don't quote me on that, but we can look at the prices. But the prices are pretty low to basically like have them have a machine running pretty much nonstop and just only charge you per request. So that's another option if people like really don't want to go into setting up their own hardware. But yeah, in general, like this stuff is kind of annoying to do certain things like in a museum or other setting like that. Yeah. Who else has questions? Go for it, Esteban.
What about the sliders that you were exploring to generate images and, just to explore the pickle?
We'll look at that next week. Next week, that is going to be, next week we'll cover GAN space. I almost got it completely working this weekend, and then I just I had a meltdown on some Runway stuff that I had to go back and fix. So I didn't get to finish it, and also clearly this class was long enough as is. But we'll cover GAN space next week, yeah. I also, Caitlin, if you're interested, I made an easier notebook. That is, the number of installs you need to do are much better. So I'll share that in the Slack channel. It saved me like 15 minutes in setup time. Yeah.
Yeah, I had to write a lot of my own pip install stuff just to fix all the things that failed. So much appreciated.
Yeah. Moises, I think you had your hand up.
Yeah, I actually had a question about these training in Square. Is if you know all your data is bounded within whatever 300 by 300 pixels, will it expand out of that just out of like its own curiosity to find patterns outside of it? Because I was almost thinking of training in, you know, the landscape vertical solution, but like creating that white space. But then I was like, oh, maybe it's gonna try to like, you know, find stuff outside. Like,
Yeah, I mean, so in those cases, it basically will not find anything new outside of those spaces. So
okay.
if you, like, I have some examples where I've like basically taken a model. I'll find the model and share it with you. It's actually sort of similar to what Kyle was training out. Kyle has like some landscape images where you stretch the edges. All it will learn is that your edges need to be stretched. So it won't actually learn anything new in those spaces. StyleGAN's model is very much set to like, we will learn about things at the spatial position they are in and nothing else. So it's generally like, if you wanted to create a thing where you would say like, hey, sometimes an image is over here and sometimes an image is over here, you want to actually build that into your data set. Sorry, I see my chat bubble is hitting up. If folks have questions, feel free to just ask me. Oh, okay, yeah, so there's some Docker images there, Octavian, if you're interested. Okay, what other questions do folks have? Anastasia, did we answer all the questions that you had from earlier?
Yes, I think so.
Okay, cool. Let me know if not. And again, I'm also like, if you have a question that is specific to your project and you don't want to ask it in the group setting, please feel free to set up a one-on-one with me, and I'm happy to answer some questions specific to your project. And just as a reminder, I think what we're going to try to do is like maybe, so next week is our last class. So I think like 2 weeks after that, we might try to set up just like a session where people can share work. And we'll probably do some fun like live stream it to YouTube. So if you want your family to come watch or your friends or whatever, like they can come join. And it'll just be like a fun like celebration. Like I will hopefully not talk as much as I talk in this class. And it can mostly be about you guys sharing work and stuff. And again, think about like, you know, a project you might want to make with that, or maybe you want to record a video and just have us play the video. Like however you feel comfortable doing public speaking is all up to you.
Yeah, if anyone's curious about that, like I'm just happy to share like a few solutions and workflows, whether you want to do anything live, whether it's performative, or you just want to, you know, have a question and answers, or it can all just be pre-recorded and we kind of create a, you know, like a seat, like storyboard of who goes, like a lineup, basically, things like that.
Yeah, if you wouldn't mind, just post that in the Slack channel. Leah and I are going to talk about it tomorrow, and then we'll also like figure out we'll figure out like a schedule for everybody before our last class.
Mm-hmm. Will do.
Cool. All right, I've kept everybody for 2 hours now. If you have any questions about stuff, like please feel free to hit me up on Slack, talk to Leah as well. And if not, I'll see everybody next week for our last class. All right, bye everybody. Thanks.
Bye.